Generative design is an iterative design process. It begins when the designer defines the idea or concept for it. They abstract rules and create algorithms from this concept, which gets formalized into code. With initial parameters, the computer interprets this code into one or more outputs. The designer judges these outputs and refines the rules and code. This cycle repeats until satisfactory results are created. Generative design is a great tool to create art in the form of 2D and 3D visuals, typography, sound, architecture, or a combination of them. It can use randomness, control randomness, hard-coded values, camera feeds, sound files, other images, text, or any kind of data as input for its algorithms. One of the generative designs that I've produced was a collaboration with a Swiss artist, Marc Tonton. For his Post-Lux Tenebras work, a commentary on the evolution of the flower power, the changing power, and the control exerted on the population by digital companies. One of the concepts we worked on was the matrix, as an interpretation of how digital services have built a reality that is much more complex than what we see a priori. We started by brainstorming the design, iterating on the original one from the 1999 movie. The tool chosen for this was the standard of digital generative art, p5.js. Colors, alphabets, sizes, speed, length and number of lines, and superposition. These were some of the variables explored for the design. There are several similar projects out there, so I had a good starting point where exploration was easier. The two final results were a 96-inch display with a rain effect, using green to evoke some of the original terminals from the flower power era. The original idea was to run the code on a Raspberry Pi. I coded the entire project on my personal computer, which was much more powerful. When I tried running it for the first time on the Raspberry Pi, it would overheat and drop frames to the point that it really affected the final result. That's why we decided to do a screen recording on my machine and loop it. One of the art pieces was just a screen with a rain animation. So to add more dimension to the artwork, we collaborated with Lucas Ubik, artist and musician, who composed some abstract pieces of music for the artwork, and this was the result. As the length and symbols are randomized inside a range, every iteration is unique. The symbols used were Cyrillic, as a commentary on the war between Russia and Ukraine, using the alphabet that the countries share. The second artwork mixes the physicality of casted flowers that drip into a rain of binary code, which from a distance looks like a curtain slightly moving. Here, as in the green iteration, we get a unique output every time the code is run. The mix between the randomness of the symbols and the length and the speed at which they show up give a unique take that wouldn't be able to produce through other Explore mediums, such as an After Effects video. Both artworks are part of an exhibition currently being displayed in Barcelona. My journey with generative design also had me questioning what can happen if there's no randomization involved. So, evoking the visual media player of my childhood, I created a visualization program for music, using the P5 sound library. Here, I used the fast Fourier transform to analyze the wavelength of an audio track and translate it into a visual experience. The fast Fourier transform is a mathematical operation that decomposes a signal consisting of multiple frequencies. It returns an array of 1024 values for every frame. Fourier transform isn't limited to digital signal processing, but that's the use I have for it on this project. I started the project with a simple visualization of how those 1024 points move. Here, we can visualize the waveform of the song composed by data such as the energy, which is how long the song is, zero crossing rate, which classifies percussive sounds, among other metrics. The second iteration was to make a circle out of it, so I curved the wave, and then mirrored it. Then added a concentric smaller circle around, which mimics a speaker. I added moving particles around it, which appear on the outmost circle and move outwards, reacting to the loudness of the music. They are disposed of once they reach the window's borders, which was done to preserve memory. After playing around with some parameters, I decided to make the background less opaque. This allows for the ghosting on the lines, which I think add an interesting touch. At first glance, it looks random, but because the same track always generates the same waves, we could post 2 or more iterations of the code at the exact same moment and we will have the exact same image. Both the motion picture and the still image are part of the desired outcome. Exploring randomization, I also found about gradient noise, and I couldn't help implementing a project based on that as well. The principle of Perlin noise, one of these gradient noise iterations, is that each point is related to its nearest neighbor's gradient values. It can be used on any number of dimensions to create outputs that resemble natural formations. For example, one-dimensional Perlin noise can make a straight line into something that resembles handwriting. 2 dimensions into a gradient map that we can use for a water, fire, or cloud representation. 3D noise can give us a world map for a video game like Minecraft, cavern systems included. And if we add time as a dimension, we can have our fire or water model move, for example. Here we can see the difference between a matrix of vectors with completely random directions. If we compare it to the matrix of vectors with Perlin noise, we can see that the transitions are much more smooth and organic looking. Gradient noise is used very commonly in generative art. Here we can see works from one of my favorite artists, Ben Kovach, all done using some implementation of Perlin noise. His work was my main inspiration for this last project. This is a small project I made using Perlin noise. It's a grid of vectors in which angles are in a range depending on adjacent vectors. Particles gain the speed and directions of the closest vector, giving the impression of a current or other type of flow. I played around with colors and backgrounds, but I decided to finally give it the same aesthetic as a previous project, with a simple but effective black and white palette. To give it the same feel, I also reduced the opacity of the background so the final result matches that of the visualizer project. This was the final result. And this was a look into my personal journey in the ever-expanding world of generative design. Thank you for watching.